interfaces are different collision domains. Then it means collision domains are actually small at the same time. There is only one line like this. So now receiving and sending data has no effect. PC1 sends data. PC2 can also send. For switch ports, you don't need to understand why it is different from the interface of the hub. This is an improvement based on physical hardware. That's what's on the hardware level. We only need to know its logical concept. And the switch's interface has a behavior. Self-negotiation behavior. Its interface can realize the negotiation of working mode. For example, the switch is connected to a hub. The hub interface is a half-duplex mode. The switch is in full duplex mode. Switches can be compatible to small. It can also be turned into a half-duplex mode. This switch is connected to a switch. The peer interface rate is relatively small. Its interface rate is relatively high. It can accommodate the other. Negotiate to a rate consistent with it. Backward compatibility. Therefore, the interface of the switch can be negotiated automatically. Each interface of the switch is independent. Then please pay attention. Once each interface is independently, it means that the data of one interface of the switch will no longer be perceived by other interfaces. So how does it work? How to forward data? We just mentioned the MAC address table. For switches, actually, it's like a brain. This brain is the MAC address table I just mentioned. I'm going to make a logo for the PC. This is PC1. The MAC address of PC1 is AA. This is PC2. The MAC address of PC2 is BB. This is PC3. The MAC address of PC3 is CC. This is PC4. The MAC address of PC4 is DD. Let's simulate data sending now. Suppose PC1 wants to send data to PC2. Then they have to complete an encapsulation of the source MAC and the destination MAC. We talked about. There are two encapsulation methods at the data link layer. One is called E2. One is called 802.3. What we use most now is the E2 package. Now the data link layer is going to be encapsulated. The encapsulation is the Ethernet 2 standard. It has a parameter in it called SMAC and DMAC. Source MAC and destination MAC. Now PC1 is going to visit PC2. Source MAC is AA. The target MAC is BB. Then if such a data is generated, prove that they have made an ARP request. Already got PC2 MAC. This data wants to be sent to the switch like this. Then let it help perform the forwarding. For switches, it received a data. First it has to learn the MAC address. That is, the switch will record the source MAC of the received data frame and the information of the incoming interface. Now this data is sent from this PC. Enter switch. The interface of the switch itself is numbered. For example, this is the interface 1, interface 2, interface 3, interface 4 of the switch. It learns locally. It only needs to receive a data from this interface. It will look at the source MAC in this data and record it in the local MAC address table. So it will now record a interface 1 corresponds to the MAC address AA. It learns like this. The first behavior after it receives the data is called learning. The next behavior is to forward. For forwarding, now it behaves differently. If it receives a data, it is a specific device to be sent to. For example, now it needs to be sent to PC2 specifically. Then it will look at the MAC address table locally. If the MAC address table has, then just retweet. There is a parameter in the MAC address table known unicast data frame. Unicast means This data is sent by PC1 alone to a certain device. That is, sent to a certain MAC address alone. And look up the table. If there is, it means that this data can know a clear destination. Known unicast data frame. If you know it, directly look up the table and forward it. What if you don't know? Now it's going to be B. But this doesn't have this BB. Then what should we do? If there is no that for this switch. Unknown unicast data frame. Now where does this data frame go? It doesn't recognize the purpose MAC. So now it will perform flooding. So if a data really comes now, it doesn't recognize the destination MAC. Then it will perform flooding. The action of flooding is to send a copy from all other interfaces. It's the same as the hub just now. It will also send. But you have to pay attention to the difference. The difference is that if there is one in the table, it will be unicast forwarded. Flooding if there is no table. If flooding, PC2 received. It will reply after receiving. When replying, this data enters the interface of the switch again. It learned again. After learning, its MAC address table can be filled. Then next time when the PC sends it again, it can look up the table and forward directly. This is how the switch works. Received a unicast data with a very specific destination. See if there is such a purpose MAC in the unicast data table. Check the table if you have. Flooding if not. After flooding, the device has finished learning. You can check the table next time. This is a processing action for unicast data. We may also have some broadcast messages. Suppose the destination MAC is now all F. When PC1 communicates with other devices for the first time. But I don't know the MAC of other devices. It has to send an ARP broadcast. Then on to the switch. The switch has received a broadcast data. Then don't think about it. Absolutely direct flooding. So you will find. The switch will also perform flooding. But it's not mindless flooding like a hub. Received broadcast or unknown unicast will cause flooding. If you receive a known MAC in the table, it looks up the table. So this is one of the places where switches are better than hubs. It has a forward appearance. Multicast we are not discussing now. Radio is for everyone. Multicast is for a certain group. So if the switch does not enable any functions related to multicast. In fact, it does not know whether the equipment below is added to the group. So you can temporarily consider it the same as broadcasting. You will learn multicast when you reach the IE stage. We don't learn this technology now. Let's make a brief summary. For switches, it doesn't actually care about the IP address of the device. It does not care what network segment the device is. It only sees the second layer when looking at the data. Switches work at the data link layer. That is the second floor. Routers work at layer 3. After it receives a data. To decapsulate the message. To which level? If it demolishes the second floor. After reading the lookup table. Re-encapsulate the second layer before forwarding. Then it means that you only look at the content of the second floor in the whole process. Don't look at the third floor. This is called working on the second floor. For routers, after receiving, must see the second floor. First of all, the destination MAC is sent to it. Yes. Look at the third floor. In the third layer, we need to look at the destination IP address. Then perform corresponding routing